So welcome back. We're going to do another short and sweet example from 2018, and this is question number 5. So the sum total of this question is 8 marks, and in my opinion it contains a very simple function that's given, so that's nice. And what it's asking is a couple of technical terms like domain, asymptotes. You're asked to sketch a graph, which is fine because you're given the function, so you can just do some computation. And then in the final question, you're asked to compute the derivative. Okay, so very simple things, but it's important that you know these technical terms in the first two questions. So the first question is, well, what's the domain of f, function f? And in the first place, we need to just quickly revise something. So when a function f is given like this is described as the function f as a function of x. Okay, and as I said in a previous video, we can also call this function h as a function of t, for example. What these letters are is completely trivial. But what's important to know is that this is the dependent variable and this t is the independent variable. Okay? And this comes in, well, if you want to know the domain, if I read out what I copied here, well, it's a well-defined function, must map every element of its domain onto the element of its codomain. So the way to think about that, because that's also very abstract, to think about that is, well, you need in the domain, you need values of your independent variable so that your dependent variable holds. Okay, so the domain contains the values of this independent variable so that the values of the dependent variable holds. And again, whatever, in this example it's f of x, but it can easily be anything else. Okay, so having said that and having recapped what the domain is, let's think about this. By looking at this equation, and I'm just going to rewrite it here. Minus 1, and that's x minus 1. Okay, so we need to think about values for this x where this function fx will not hold. Well, by inspection, you can clearly see that if I give the value of x 1, this value at the bottom will turn to 0. So for the value of f, x1 will be a minus 1 divided by 0. Well, that's undefined, right? And so that is a value that should not be included into the domain. It's x equals to 1. By inspection, again, you can see, well, kind of for all other values of x, this equation will hold, right? So the way to write this then is, well, for values of x, all real values of x, these all count, except where x equals 1. Because then you get an undefined function. That is the answer. Cool. The next question then asks, well, write down the asymptotes of f. Well, asymptotes is where this function f does not hold. Okay? And it's not defined. It's important to know that, well, if we first think about that, that's fx, that's the y-axis typically drawn as, and that's the x-axis, right? Well, the first thing you can think of intuitively is that a function can have a vertical asymptote, potentially, but it can also have a horizontal asymptote, okay? So as you answer this question, it's important to keep in mind that you can define both vertical and horizontal ones. So let's first look at vertical asymptote because that defines the functions of f of x that does not hold. And we already saw from 5.1 that when this x value as a value of 1, well, then the function fx is undefined. So the first asymptote that we can see by inspection of this equation is a vertical one, and that's for the value of x equals 1. Okay, so I'm going to write this here. A vertical asymptote is for the value x equals 1. Okay. But also I can have a horizontal one, and this will then correspond to y values, right? Now, how you then find the asymptote is it will be where this function fx has a contradictory value. Okay, and this is a little bit abstractly said. What you can see then is on the top here you have -1. So you always have -1 regardless of what the x values are on the top. Okay, but what you'll see is if I choose this fx value, which sits on this y-axis here, as 0, well, then you have this contradiction, right? You have 0 equals -1. This can never be. And so that is a candidate for a horizontal asymptote. Okay, so the horizontal one is at y equals, well, 0. And this I should correct, because that equals x equals 1 is the asymptote. Okay, I hope all of you see that, and if we can draw that in, what I did to save some time and to make things a little bit neater is I took this function and I programmed it into R. Okay, and I plotted it from -5 to 5 on the x-axis. Okay, so here I have -5 and here I have 5. Okay, and this is the x-axis. This is the y-axis. Okay, not drawn very neatly, but you get the idea. So that's y equals f of x, and this is x. Okay, what you can see then is exactly what we described. This function has an asymptote. Just draw that in neatly, as neatly as possible, I guess. It's got this vertical asymptote at x equals 1. And it's also got a horizontal asymptote then, where the function never ever reaches a value at x equals 0. Okay? And so if we look at our solution, and we look at the graph, we see, hey, but that makes sense. Okay, and again, to go back, the vertical one is also done by inspection, and you can see, well, it's where the function will be undefined, and we could see, hey, if I give this x a value of 1, we have something divided by 0 that's undefined, and so that's the vertical asymptote. And for the horizontal asymptote, we had to look for values of this function y, where we get this contradiction, right? Y can't be -1. And so for this example, at y equals 0 of the function fx equals 0, that's where we have our horizontal asymptote. Cool. Next question is, well, sketch this graph. I did it using R because I'm lazy. You'll have to do that with pen and paper. That's very easy. You can just choose a couple of points on the x-axis. You have this function, and all you need to compute is the corresponding function values and draw it. Okay? for example, I can choose, if I had to do it by hand, I would probably choose the point x minus 2. And then that would be, so that's your x values, that's your y values. And I would have minus 1 divided by minus 2 minus 1, and I would get a third. Something like that. Okay, and you would do that for a couple of values, get a table and just draw it. And then for the final question, well, you're asked, well, for which values of x is this complex thing is equal or larger than 0? Okay, by inspection you can see, well, what I need to first compute is the derivative of this function fx. Okay, very little marks, so it shouldn't be difficult. Let's have a look. I have f of x given. I'm going to write it in a slightly different form. Have a look here. I'm keeping this minus 1, but I'm bringing this bottom bracket up and giving it a power of minus 1. Okay. If you don't know what I did here, it's important to realize that everything above the line, or like x above the line, would have a power of 1. But as soon as it goes below the line, it has a power of 1 too. And as soon as you bring something from the bottom to the top, you put a minus in front. Okay? Now, because you know this power here, computing the derivative is a little bit more elegant, and I thought a little bit more easy to understand. So you have this minus 1. Then I have to compute the derivative of this, right? So it becomes minus 1. That bracket stays constant, right? So it becomes x minus 1. And I have to subtract minus 1 from there. So that's minus 1, minus 1. And then I have to compute the derivative of something inside of the bracket. Well, the derivative, which here is defined as df dx, the derivative of x is just 1. So it's easy. So what you get is 1 over x minus 1 squared. That's f prime. Okay, and so what they want is the value of x over x minus 1 squared. The x values where this function is larger than 0. Or equal to 0. Okay, so let's start with equal to 0. Well, that's where x is 0, right? So for x value equals to 0, this function is 0. And remember, the key is here. Very clear clue is the second derivative. Okay, not second derivative, second power. So whatever the value of x is going to be here, even if it's minus, the square is going to make it positive, right? So if we have minus 1, this is going to be minus 2 to the square. That's going to be 4. Okay. So let's have a look. I'm going to write that out and not just say stuff, so that it's a little bit more clear. So let's say, for example, we choose the value of x minus 2. Then we get minus 2 minus 1 to the square. That's going to be minus 2 over 3 minus 3 to the square is minus 2 divided by 9. That's smaller than 0, right? That's negative. Okay, so we'll have to choose values of x, therefore, larger than 0, or positive. Let's just say it like that. Okay, that's the first important thing to realize. So positive values, and again we're stuck with this thing. of this value here at the bottom of the bracket can't be 0 because then the function is undefined. So it'll be for all the values of x, if we combine these two, larger or equal to 0, except for x equals to 1. Because that's when this function at the bottom here is also undefined. And that's your solution. That was 2 marks.